There is a 4-metre constrictor lying dead in the brush just outside a protected conservation tract in southern Ontario, and its head has been torn clean off. Early winter, late 2022. It was a discovery that left a veteran team of field biologists standing in stunned silence over the frozen earth. For 6 seasons, researchers with the Regional Conservation Authority had tracked this single apex invader, a massive male designated Loki, a name about to take on a strange, poetic resonance across these northern wetlands. He mattered to the tracking program, and not simply because of his sheer scale. When the crew followed his radio telemetry pulse deep into a stand of hemlock and cedar on Crown land that frigid morning, they found his frame half buried beneath a deliberate mound of pine needles and damp leaf litter. His head and cervical vertebrae had been severed, gnawed away and concealed under the forest floor, like evidence someone was trying to hide. Whatever accomplished this was entirely undaunted by a serpentine behemoth capable of suffocating and consuming native white-tailed deer whole. That single headless carcass was about to reveal a clandestine ecological war playing out across our wilderness, right under our feet. To grasp why Loki's demise halted seasoned biologists in their tracks, you have to examine the history of this invasion. For more than 2 decades, across the recorded spread of invasive constrictors in these southern wetlands, nothing native to Canadian soil had ever been documented taking down a giant adult specimen. These foreign predators landed in our river systems without a single natural enemy capable of standing up to them. Burmese pythons naturally belong thousands of kilometers away in the jungles and marshlands of Southeast Asia. They rank among the most formidable serpents on the planet, easily exceeding 5 meters in length and pushing past 90 kilograms at maturity. Throughout the late 20th century, they became coveted status symbols in the North American exotic pet trade. A captive hatchling is an unassuming creature no thicker than a pencil, placid and easily cupped in the palm of a hand. Exotic pet stores across the continent sold them by the thousands. The crisis stems from what that fragile hatchling inevitably becomes. Within a few short years, that novelty pet transforms into a 4-meter apex predator, requiring whole rabbits for sustenance and bursting through any indoor enclosure an amateur keeper can construct. Overwhelmed owners across the region did precisely what provincial wildlife ministries pleaded with them never to do. They loaded their vehicles, drove to remote access roads skirting our southern marshes, and slipped them into the wetlands. Then came the ultimate environmental catalyst. Severe storm events and structural failures at regional exotic breeding facilities and warehouse compounds shattered containment enclosures along rural boundaries. When those walls collapsed, an untold number of heavy constrictors dispersed silently into vast wetland habitats. Nobody planned the breach, and no provincial agency possessed the immediate resources to halt it. The invaders were loose, entering an expansive mosaic of river bottoms, cattail marshes, and sheltered thermal microhabitats that proved remarkably accommodating to our southern wetland complexes, offered a paradise of dense reed beds, sluggish waters, and abundant prey. Native wildlife had evolved over countless millennia without ever encountering a massive ambush constrictor. Our local fauna possessed zero evolutionary memory of this hunting strategy, no instinctive dread, no evasion tactics, and no biological defense against strike and constrict tactics. Most critically, nothing swimming or stalking through our Canadian wetlands possessed the size or predatory instinct to hunt an adult constrictor. No native canids or standard local carnivores could challenge an established giant. Biologists estimate that thousands of these silent invaders now inhabit southern watersheds, yet fewer than 1% are ever detected by human eyes. For every massive serpent extracted from the marsh by conservation officers, roughly 99 remained camouflaged in the reeds. What followed was one of the most abrupt ecological disruptions ever recorded in the country. Collapsing native small mammal populations at an astonishing rate, the anatomical machinery of these constrictors is engineered for total consumption. A constrictor does not possess a rigid, fused jawbone like a human. Instead, the two halves of its lower mandible are connected solely by an elastic ligament, permitting the mouth to open drastically wider than the serpent's own skull, while flexible ribs expand to swallow oversized prey. In late 2022, the very scientific team monitoring Loki documented an invasive constrictor successfully swallowing a mature white-tailed deer whole, a mammal that outweighed the predator ingesting it. The inventory of species retrieved from the digestive tracts of these invasive snakes has climbed past 80 native Canadian animals, ranging from waterfowl and migratory songbirds to semi-aquatic mammals and medium-sized carnivores. Wildlife managers quickly recognized that introducing a foreign biological control agent would be disastrous, risking secondary invasions that devastate native bird populations. Whatever force was going to challenge these giants had to emerge organically from within our native biodiversity. For a quarter of a century, the wilderness remained silent. That brings us back to Loki's identity. He was not merely an untracked wild snake. He was a 52-pound male that biologists had transformed into an undercover biological tracker. During the winter breeding cycle, mature males actively navigate through frozen marshes, searching for receptive females. Conservation researchers capture a robust male, surgically implant a high-frequency radio transmitter into his body cavity, and release him back onto Crown land. By tracking his movements through dense ground cover, crews are led directly to aggregations of breeding females. Eliminating a single fertile female erases up to 100 viable eggs before they can hatch. In conservation terminology, these tagged subjects are designated Judas snakes because they systematically betray their own species. For 6 consecutive seasons, Loki served as one of the most reliable tracking assets in the entire provincial monitoring project, exposing breeding cluster after breeding cluster. In Norse mythology, the trickster Loki was bound beneath the earth with serpent venom dripping constantly upon his head. The field biologists certainly had an ironic appreciation for the name. When Loki's telemetry ping led the field crew to that isolated patch of ground, they anticipated finding him coiled securely alongside a breeding female. Finding his massive trunk decapitated and deliberately buried beneath forest litter changed the nature of their field study completely. The act of concealing a large kill, a distinct predatory behavior known as caching, is practiced almost exclusively by wild felids. Across this provincial landscape, that evidence narrowed the investigation down to 2 potential suspects. The first suspect was a solitary cougar, a powerhouse capable of overpowering large prey, yet confirmed sightings in this jurisdiction remain vanishingly rare. The second suspect was the native bobcat, a compact feline rarely exceeding 11 or 12 kilograms. The physical comparison seemed preposterous. Loki outweighed any local bobcat by more than double. How could a compact native wildcat sever the head of a massive constrictor that swallows adult ungulates? To solve the puzzle, researchers partnered with federal wildlife specialists and deployed automated trail cameras directly facing the concealed carcass, anticipating that the mystery predator would return to its cached meal. Within 24 hours, the camera sensors triggered. Emerging boldly through the dense brush toward Loki's hidden remains came a lone, fully grown native bobcat. Weighing barely 12 kilograms, the cat moved with absolute authority, testing the air for human scent, patrolling the perimeter, and settling down to feed upon the 52-pound giant it had conquered. It was an astonishing triumph for native fauna against an overwhelming invasive force. The secret behind the feline's victory lies in reptilian physiology. As ectothermic animals, large constrictors cannot generate internal body warmth. Their metabolic rate, strike speed, and muscular constriction power plummet whenever ambient temperatures drop. A sudden early winter freeze had locked the wandering giant into a state of near paralysis, and the quick-witted native feline exploited that fleeting vulnerability, striking at the immobilized predator and reversing decades of invasion dynamics. To fully appreciate the gravity of that motion sensor footage, you have to look closely at the catastrophic imbalance that has defined this ecological standoff for decades. When foreign apex constrictors first took root in our expansive southern wetlands, the established food web had no natural answer for them. This was an invasion operating without checks or balances. Biologists conducting nocturnal spotlight transects along hundreds of kilometers of rural access roads and canal networks across southern conservation corridors began recording staggering drops in native wildlife densities. In zones where these giant serpents established dense breeding pockets, sightings of mid-sized native mammals plummeted toward absolute zero. Raccoons, Virginia opossums, and local red foxes, creatures that had flourished along our waterways since the retreat of the glaciers, were practically erased from entire wetland sectors in less than a decade. The bottom fell out of the ecosystem with a speed that shocked even seasoned conservation authorities. For years, some skeptics questioned whether a single introduced reptile could truly be responsible for such sweeping ecological collapse across temperate wetland systems. To test the hypothesis under rigorous scientific scrutiny, wildlife researchers initiated an intensive telemetry experiment. Biologists fitted native marsh rabbits and hares with miniature radio collars and tracked their survival rates in areas known to harbor invasive constrictor populations. The findings were undeniable and devastating. Within less than a year, invasive constrictors accounted for more than 3/4 of all rabbit mortality in the study zones, and within another season, the local rabbit populations had been entirely extirpated from the monitoring perimeter. The snakes were not just participating in a shifting ecosystem, they were actively gutting the entire intermediate predatory tier. What makes the encounter between Loki and that native bobcat so profound is that it directly inverted an established, brutal dynamic. Constrictors eat bobcats. That is not theoretical speculation or sensational field lore. During routine necropsies performed at provincial diagnostic laboratories, veterinary pathologists examining the digestive tracts of culled invasive constrictors have repeatedly extracted the claws, fur, and skeletal remains of adult wildcats that had been ambushed, crushed, and swallowed whole. The pressure placed on native felines operates on two distinct, destructive fronts. The primary threat is direct predation, where a concealed constrictor strikes from the cattails, snaring a prowling bobcat or ambushing vulnerable kittens near their den sites. The secondary threat is far more insidious: absolute resource depletion. Bobcats and constrictors compete for the exact same prey base: the waterfowl, muskrats, voles, and native lagomorphs that sustain mammalian carnivores through harsh seasonal shifts. When an invasive population consumes tons of foundational biomass, native predators quietly starve out it. The feline standing over Loki's decapitated remains had survived both threats. It had endured the systematic emptying of its hunting territory and turned the tables on a 52-pound giant that possessed every physical tool required to kill it. The key to the encounter was an absolute clash of biological design during a critical environmental window. Mammals are endothermic. Their bodies burn energy internally to maintain a constant, regulated core temperature, regardless of plunging outside air. A bobcat hunting in near-freezing conditions remains explosive, nimble, and razor-sharp. Its neural pathways fire instantaneously, and its predatory instincts remain at peak efficiency, even as frost forms along the margins of the marsh. Reptiles operate under an entirely different physiological reality. An ectothermic constrictor depends completely on external thermal gradients to fuel its cellular metabolism. When a sudden Arctic air mass pushes down from the north, driving regional temperatures toward freezing, a massive serpent experiences a catastrophic metabolic slowdown. Its muscles stiffen, its optical reflexes stall, and its predatory strike slows from an instantaneous blur to a sluggish, clumsy lunging motion. Loki was caught in the worst possible circumstance. Driven by deep reproductive hormones during the late-season breeding window, the male had left the safety of deep, thermally insulated burrows beneath root hollows on crown land to cross open terrain in pursuit of a female's chemical trail. When the thermometer plummeted overnight, his physiological defenses shut down in the exposed underbrush. The resident bobcat did not encounter a lightning-fast constrictor operating at full summer power. It encountered a massive, immobilized leviathan struggling simply to contract its core muscles. And the native predator capitalized on that narrow vulnerability with absolute clinical precision. A bobcat is an evolutionary master of dispatching dangerous quarry quickly, focusing its bite force directly on the base of the skull and the cervical spine. By severing the spinal cord behind the head, the cat neutralized the massive snake's nervous system before those 52 pounds of muscle could coordinate a defensive coil. It was an extraordinary demonstration of opportunistic predation, a native Canadian wildcat identifying a weakness in a foreign giant and seizing the moment to feed. That solitary victory on a frost-draped morning in southern Ontario represents far more than an isolated anomaly on a remote wildlife corridor. It signals the earliest ripples of an evolutionary counteroffensive. For more than 2 decades, the ecological dynamic between native Canadian fauna and these massive foreign constrictors appeared entirely one-sided. The serpents expanded through wetland systems virtually unopposed, stripping clean the native biodiversity across regional river valleys, provincial park reserves, and designated conservation tracts. Yet, as researchers examine the broader field data pouring into environmental databases and provincial wildlife monitoring centers, evidence is mounting that our local ecosystems are quietly beginning to push back. The bobcat's lethal strike against Loki is part of an emerging, uncoordinated pattern of native behavioral adaptation. In the early stages of any severe biological invasion, native predators treat the foreign species with profound avoidance or fatal curiosity. They possess no inherited hunting scripts to engage an organism of such immense bulk and alien movement. But as generations overlap in contested habitats, local carnivores and opportunistic omnivores begin deciphering the behavioral boundaries and biological constraints of the newcomers. Field crews operating across southern watersheds have started observing native predators capitalizing on the unique vulnerabilities of these giant reptiles during extreme meteorological swings. Consider our native avian raptors and apex scavengers. Golden eagles, bald eagles, and great horned owls hunting along the edges of broad cattail basins and marsh complexes have been documented targeting juvenile constrictors, basking along open dikes and exposed sunning mounds. In the invasion's earliest years, young serpents moved through dense canopy and shoreline undergrowth with almost complete impunity, completely unbothered by native birds of prey that had never encountered a heavy-bodied, constricting juvenile. Today, wildlife rehabilitation officers and field researchers report growing evidence of large raptors actively taking immature snakes out of open marsh channels, turning an unchecked invasive reproductive surge into a high-protein food source for native broods. Even our aquatic apex predators are entering the arena. In deep northern river deltas and expansive wetland sanctuaries where snapping turtles grow to prehistoric proportions, these heavily armored native reptiles are demonstrating their own ruthless adaptability. While an adult constrictor can easily ambush and crush juvenile turtles, mature snapping turtles boast jaw-crushing pressures capable of cleanly shearing through bone, cartilage, and heavy serpentine muscle. Biologists conducting wetland biodiversity surveys have recovered several partial constrictor carcasses bearing the distinct, jagged bite signatures of mature snapping turtles that confronted the serpents underwater, where the cold-blooded invaders lose speed and maneuverability far faster than well-insulated native chelonians. This biological pushback is entirely organic. No provincial ministry or federal wildlife management agency train these animals to hunt invasive constrictors. There is no artificial ecological conditioning taking place. This is natural selection and behavioral plasticity operating in real time across Canadian wilderness corridors. Each recorded kill represents a local creature exploiting a physiological window, whether that window is an early winter freeze, the vulnerability of an exposed juvenile, or the momentary distraction of an adult serpent locked in reproductive search patterns. And unlike human intervention programs, which operate under budgetary constraints and jurisdictional boundaries, an apex native animal that masters the art of hunting an invasive threat passes those behavioral strategies directly to its offspring and alters the competitive balance of its local territory indefinitely. Yet we must avoid viewing this through the lens of romanticized folklore. The sudden death of a single-tracked giant like Loki does not signal that the wilderness has miraculously cured itself. The sheer mathematical velocity of this reptile invasion remains staggering. A single mature female constrictor can deposit between 50 and 100 viable eggs in a single spring clutch, hidden deep within decomposing vegetation mounds or hollow subterranean logs, where incubation temperatures remain remarkably stable. Within 60 days, those eggs yield dozens of fully formed independent predators capable of hunting immediate prey within hours of emerging. The sheer reproductive throughput of an established constrictor population can overwhelm native predation pressure through pure numerical saturation. The bobcat strike is a vital sign of systemic resilience, but the broader landscape remains under immense structural pressure. Because nature's pushback moves at the slow, incremental speed of evolutionary time, the immediate defense of our southern wetlands still rests squarely on human shoulders. Across provincial conservation zones, crown game reserves, and delicate municipal watershed corridors, dedicated field biologists and contracted invasive species technicians remain the primary barrier against total ecological collapse. Every season, specialized teams head out into the backcountry, equipped with thermal imaging arrays, GPS tracking receivers, and high-tensile capture gear, paddling through freezing marsh tributaries late into the night. Their operational mission is unglamorous, physically demanding, and relentless. Identify, extract, and permanently remove the giant reproductive females before their massive clutches hit the forest floor. This is precisely why Judas snakes like Loki represent such an indispensable tool in the national conservation arsenal. Tracking a solitary camouflaged serpent across thousands of hectares of trackless wetland brush is virtually impossible through direct visual search alone. By leveraging the biological drives of a surgically tagged male, researchers turn the invader's own reproductive biology against them. When an implanted male seeks out a mate during the critical late-season breeding window, he cuts through millions of square meters of dense ground cover to pinpoint hidden nesting clusters that human searchers would never locate. Locating and removing even 2 or 3 gravid females through a single tracking run eliminates hundreds of potential apex predators in an afternoon, creating an ecological impact that no amount of native predation could currently match. The loss of Loki closed a 6-year chapter of continuous data collection, but the revelation left behind on that trail camera will endure in ecological field research for decades. In that single frozen frame, the narrative of an unstoppable foreign invasion fractured. A 12-kilogram native bobcat, representing a local mammal population hammered by 30 years of ecological displacement, stood victorious over a 52-pound apex constrictor that had dominated the local food web. It was definitive, tangible evidence that our northern ecosystems possess a profound, stubborn capacity for resilience. When given even the narrowest physiological opening, the indigenous wildlife of our country will find a way to challenge, exploit, and push back against the most formidable biological invaders on Earth. Our wilderness is neither fragile nor passive. It is an active, evolving battleground where the rules of survival are constantly tested and renegotiated. The arrival of massive foreign constrictors dealt a severe blow to the native balance of our southern wetlands, but the story is far from concluded. As seasonal frost cycles continue to test the thermal thresholds of these invasive reptiles, and as native predators from stealthy wildcats to apex raptors continue to integrate them into their predatory repertoires, the wild is slowly forging its own answers. The struggle to preserve the biological heritage of our wetlands will demand years of coordinated conservation management, diligent field research, and public vigilance across every watershed boundary. But on that quiet, frost-bitten morning in southern Ontario, a solitary native predator reminded us all that the wild has not surrendered its territory. The wetlands are learning, adapting, and fighting back for every inch of crown land.